Hello guys, welcome back. So in this video, we will implement k-nearest neighbor algorithm for the purpose of regression from scratch. Okay. So we will purely make use of numpy. I will not be using any machine learning libraries such as SKLEARN. Okay. So let's start. So I have imported some of the libraries that I will be using. So numpy, pandas, and we will time it. How much time it will take for a KNN to complete. Okay. And for visualization, we will use matplotlib library. Okay. So here, using numpy, I am reading two CSV files. One contains the training data and another contains the test data. So both are separated by commas. The delimiter is comma for that. And I am reading both of them using gen from text method. Okay. So generate from text. So this is a numpy method which will generate a numpy array from the files whatever we have given. So it will read and create a numpy array for us. So I have read it in two separate variables, train data and test data. Okay. And this particular data set is not having any missing values or any such things which we may need to deal with. Okay. So it has all the required data and none of the missing data set, none of the missing data in this data set. Okay. So if you check the shape of train data and test data, so training data has around 6,400 records and test data has 1,600 records. So this is the data set against which we will be testing the performance of our KNN regression. Okay, and we have 13 columns. So out of these 13 columns, the last column is our target variable or the regression variable or the dependent variable, the last column. Okay, the remaining 12 columns are our independent variables. So this is how the data set looks, and we will start implementing the KNN now. Okay. So in order to implement KNN, we need to read the data as a first step, which we have done already. For each query instance, we have to calculate the distance with the training instances. Okay. So we have 1,600 test data, right? So these are our query instance. For it, we have to predict the regression value. So this, for each of the 1,600 test data, we have to calculate the distance with these 6,400 training data. Okay. So total distances that we are going to calculate is 6,400 into 1,600. So it's a lot of calculation. You do the math, so you will come with some huge number. So many distances we have to calculate, and out of that, we have to consider only k nearest neighbors. So we have to sort in ascending order depending upon the distance that we have calculated, and then consider only k of the nearest neighbors and assign the average value to our query instance or the test data. Okay. So in this particular implementation, forget about what the data represents. So the whole idea of this video is to give you an understanding how we can implement KNN regression in Python from scratch. Okay, so let's forget about what each column represents and what we are predicting. Okay, so it's a regression column. Just understand this way. It's a regression problem, and we are predicting some continuous values. Okay, so now we have seen the 4 steps of the KNN. We will start implementing one by one. So we have already read the data. So the first step is done. So each row represents one training example in the train data, and in test data, each row represents one query instance. Okay. So we have read already. Now we have to implement the function, define a function which will calculate the distance. So in this case, we will use Euclidean distance, and let me create a function by name define calculate Euclidean distance. Okay. And what we need all the training features, right? We do not want the regression variable. We need the training features to calculate the distance. Okay. So the distance between any query instance and the training instance is calculated using the features value that we have. Okay. So that we have passed, and then we want individual query instance, right? So it will be query features. So please note this will be the training feature shape will be 6,400 by 12. Okay. Since we are not considering the target variable, the last column, right, to calculate the features, it will be 12, and the rows will be 6,400. So many records, and this query features, it will just be one query instance whenever we call this function, one query instance with 12 columns. Okay, so this is what the function skeleton looks like. Now to implement the Euclidean distance, you can relate it to Pythagoras theorem, right? So we will implement it using Python. So what we have to do, we need first square root, right? np dot square root, and then we need np dot sum, and then we need np dot square. So what are all these stuffs? So you guys already know that the Euclidean distance, in order to calculate the Euclidean distance, we take the square root and then sum of the squares of the distance between each features, correct? So that's what we are doing here. So first we are squaring, then we are taking the sum, and then finally we are taking the square root of the whole sum. Okay. So now we will take the square. So what we need to square? We need to square the difference between query features and training features, correct? And this one we have to do along some axis, right? So if you guys are aware on the numpy array, how we can perform the operations on row and column wise, you guys would already guessed it. We need to specify axis is equal to 1, right? This is along the rows, but axis is equal to 1 stands for columns, correct? So each column will be considered on each row, right? So if you guys have not seen my video on numpy array, understanding the dimension and axis features, so I would suggest you to please go and watch it and then come back to this particular video. Okay. So now we have specified axis is equal to 1. This whole thing is part of sum, right? np dot sum, and then we are taking the square root. Okay. So now we have to return this. You can assign it to some variable and then return that variable, or you can simply return the calculated value, right? So this is how we calculate the Euclidean distance. So I'll just name it function to calculate Euclidean distance. Okay. Now we need function to predict, right? So we will predict with the help of third and fourth step, correct? So I will create a method, I'll name it function to predict using k nearest neighbors. Okay. So I will name it as define predict. So what all we need? We need train data, test data, and number of neighbors we need to consider. Okay. So this is what the arguments will look like. Then I'll assign k to neighbors that we are passing. Okay. So that will be the number of neighbors that we want. Now before predicting, we need to calculate the distances, correct? So let me create a variable distances and then I will call calculate Euclidean distance. Okay. So this is the function that we have defined, and what we need to pass? We need to pass this train data, right, without the last column, correct? So how we can pass that? We need all the rows, correct, and from 0 to last but one column we need to pass the training data. So this will give us 6400 by 12 records. Okay, that will be the shape of this particular numpy array. Okay, now we have passed training data. Similarly, we have to pass test data as well, but this particular test data, what we will be passing to the predict function, will be single instance every time. So it will be single instance. We have to pass that whole row except the last column, correct? 0 to -1. So this will give us one row and 12 columns. Because this will contain one row, 13 columns, we are passing everything except the last column, right? 0 to -1. So this is how we call the method calculate Euclidean distance. Now we have distances calculated. Now we need to sort the distances in ascending order. So it will be a costly affair to sort the distance and take the top k distance, k neighbors. So what we will do? We will create a variable indices and then use np.argsort, okay, and we will pass distances to it. Okay, So at every call of this predict method, this distances will have 6400 distances, correct? So this arc sort will sort the distances and then return us the position of the index in a sorted way, right? These distances will not be sorted. Let me show you some example. Okay, let me create an array np dot array array, and okay, so I have 1 2 3 4 5 6 in a randomly arranged manner, right? Now if I say np dot arc sort of arr1, you see it will return me the indices. These are not the values, but these are the indices in an ascending order. So this will tell us the element at the first index is the smallest, element at the 0th index will come after this element at the second index will follow the element at the 0th index. So it is like this, right? So if you see, the element at the first index is 1, the element at the 0th index is 2, the element at the second index is 3, the element at the fifth index is 4, correct? 0 1 2 3 4 5, correct? And element at the fourth index is 5, and element at the third index 0 1 2 3 is 3, that is 6, correct? So this is how arc sort works. Hope you guys got an idea why we are doing like this. Okay, now that we have this indices, okay, all we have to do is we have to get the predicted value, correct? Now that we will have the predicted value sorry, predicted value will be np dot mean. We will just assign the mean value of these k neighbors, right? So how we can do that? Np dot mean train data of what training data we need to consider? We need to consider this one, right? So we have to consider only k nearest neighbors, correct? So what I will do, this will give me the sorted indices, then I will just make use of just k rows out of it, okay, 0 to k, right? And then I just need the last column, correct? So minus 1 will fetch me the last column. This will be with respect to the number of rows or the number of training records that I have to consider based on the indices that I have in the sorted manner. Okay, so k can be 1 2 3 4 5 anything, okay, and I want the last column, correct? So this is my predicted value. Now that I have a predicted value, I will just return this predicted value. Okay, now we are done with predict method. Then in order to measure the performance of this particular KNN, that's it guys, this is how we implement KNN, right? So we can be sure that this works. We will check it in a while, but before we check it, we need a way to measure the performance of this KNN algorithm. Okay, so we will make use of R squared score. Okay, so I will define a function, I'll call it as calculate R square. So I'll just name it like this, and what are the arguments will be? It will be actual, target values, and predicted target values, correct? So these are the two arguments. Now if you guys remember the R squared formula from my previous video wherein I have explained about R square and adjusted R square, so we need, the formula is 1 minus SS residual divided by SS total, correct? So we need numerator and denominator separately so that we can easily write it in Python. Okay, so first I will write sum of squared residuals. Okay, so that I have noted it down in a separate notepad here, so I will just copy it. That is np dot sum. We will be taking the squared difference between the predicted and actual value. So this is nothing but the square residuals, right? Predicted and target values, predicted and actual values. If we take the difference, it will be the residual. So we are taking the sum of the square of the residuals, right? Sum of the square residuals. So this is how we implement np dot sum. We take the square of the residuals and then sum them, correct? So this is how we calculate this is our numerator part of R2, R square score. Okay. Now I am calculating the denominator part, that I will be calling it as sum squares. Okay, sum underscore squares. And how am I calculating it? So this is the difference between mean of the actual target value to the actual target value. Okay. So if you guys remember the denominator part of the R squared formula, so this is how we calculate, right? So y minus y mean, correct? So that's what I am doing it here. I am subtracting the actual target values from the mean values of the target value. So np dot mean of actual target values minus actual target value, and I am taking the square of it, and eventually I am summing it up. So this will give me my denominator part. Okay. So now in order to get our R2 score, I will create a variable R2. All I have to do is 1 minus, I have to calculate it like this, sum square residuals divided by sum of squares, correct? So this is my R square value. So this for us should be close to 1. Okay. So we will see what value we will get. So I will say return R2. Okay. So now I am done with calculating the R square. Now all we have to do is we have to execute the k nearest neighbor algorithm. Already we have read the data set. So we have to call this predict function. So how do we have to call this? So we have to call this predict for each test instance, right? We have to call this predict function for 1600 times. So how can we do that? We can make use of for loop. Okay. Now in order to calculate the time, how much KNN takes with this much data set, I will say start time equal to time dot process time. Okay, this will initiate it, this will start the timer. Okay, now I will create a variable called as predictions. It will be list. So I will store prediction of each test or query instance in this particular list. Okay, and then I will create neighbors, and let's say I am initially considering 3 neighbors to predict the value for our query instance. Okay, so these are the 2 variables that I would need, and then for I in range of length of test data, correct? So test data has 1600 query instances. We have to run this KNN 6 for each of the query instance, correct? So what we have to do? We have to call predict, right? Predict is a function, right? We have already defined here. So predict, what we have to pass? We have to pass train data and test data of I. We have to send each individual query instance, and for each individual query instance we have to calculate the distance with the all of the training data, right? So we have to send all of the training data and then individual query instance, right? And then comma how many neighbors we are considering. So for each of the test instance we cannot modify the neighbors, so it will be a better idea for us not to pass the neighbors. So instead we can directly assign k equal to 3 here. Okay, so we can change it in this particular function if we want to increase the number of neighbors or reduce the number of neighbors. Okay, so I have removed an argument called neighbors from the predict method, and I will execute it again. Now I don't need to pass this, and I don't want this particular variable. Okay, and then this predict will return me some value, correct? So this will be a single value, single number, because we are taking the mean of it. Okay, so I have to assign it, correct? I will say predicted value is equal to, okay, and then I will append this predicted value to this particular list. Predictions dot append I will say predicted value. Either you can use this or you can directly call predictions dot append, and then instead of this particular variable you can directly call this within this particular bracket, so that you will have the list appended with each predicted value. Now that we have all the predictions, we have to calculate our R2 score, correct? So for that I will say R2 score is equal to calculate. R2 is our function, right? So what does it take? It takes actual target values and predicted target values. So we need from the train data, we need only the last column. Okay. So for that, what we'll do, not from the train data, but we are calculating it against the test data, correct? So what we need, the last column, test data, we need all the rows and the last column. Okay. That is all rows and then -1 is the last column. Okay. And then we will say np dot array predictions. I'll just convert this particular predictions list into numpy array. Okay, so that both the variables will be compatible while calculating this particular R square score. Okay, so that's it. We have got the R square score. Now I'll just stop the timer, and time is equal to time dot process time. Okay, and then we'll say print R2 score is, I'll just print R2 score, and then I want to check how much time it takes, right? Time taken to complete the algorithm is, that will be end time minus start time, correct? So I have my start time here and then end time here. So we'll see how this works. So there are some errors. It says predicted value is not defined. So why it is, I think there is a mismatch with the case. Okay, so it's in the predict, see here, so this is a small and this is capital, so that's the problem. Now if I execute, so see, R2 score is 0.81, right? So we wanted R2 score to be close to 1, we got it as 8.81. Time taken to complete this algorithm is 1.40625. Now we will see how the predicted and actual values look like, okay, from the test data set. So for that, let me plot scatter plot, scatter np dot arrange. So that is length of test data. This will be my x-axis, and then test data of all rows, comma, -1, the last column I want. Let me give the color to the actual values to be yellow. So the actual values will be in yellow color. Okay. Now similarly, I will plot predictions as well. Okay. So predictions, and I want it to be, let's say, blue. Now if I plot it, it says color is invalid keyword argument for a range. Okay, so I have given everything for a range, so it should be, I should be closing it, right? A range is closed here, I have to close it. It says something not valid. Okay, there is an extra bracket. Now you see, our yellow colored values are actual values and blue colored values are our predicted values. So since there are 1600 records, this will look clumsy. We will see for only first 10 records how our prediction is working. Okay, so what we can do, we need only 10, right? So I'll just name it as 10. Okay, and test data I want only 10 rows and last column, and same goes with prediction, correct? So this is, if I execute it now, I have to close the bracket. So what happened here? Okay, now you see, yellow is our predicted value, blue is our actual value. So you see there is some difference. Some of the predicted values are close to the actual value, but most of them are far away, right? So how we can improve this? So there may be some issues with the distance methods that we have used, Euclidean. It may not be the proper one, or there may be some features which are bringing down the R2 score or predicted values. Okay, so how we can check that. So in order to do that, let us check the correlation. Okay, so we'll see. I will convert this train data and test data into into data frame so that we can check the correlation in an easy way. So now if I check df train dot core, this CORR is a method which will give the correlation among all the available columns. Okay, so this 12th column is our prediction actual target value. Okay, so we have to check the correlation of this particular 12th column with other columns. So of course, if you check the diagonal, each column refers to itself, so it will be highly correlated. The value will be always 1. So we have to exclude the 12th column for the 12th row and then check all these other values. Right? If you check, this is very lightly correlated. You can say not correlated. The same thing goes with the first column. This is 0th column, first column, third column is also not so much correlated. Fourth is also not correlated. Fifth is also not that much correlated. The correlation value is very, very small. The sixth one is all the fifth column, right? It is also very small, lightly correlated, or you can say not correlated. But starting from the sixth column here, the correlation coefficient is 0.5, 0.48, 0.15, 0.46, and again this particular 10th column is not that much correlated with the target value. It is very small value, and the 11th column is 0.50. So we will make use of only these particular features which are giving high correlation coefficient. Okay, so how we can do that? So from this you can see we need to make use of these. We can ignore first 5, right? So first 5 can be ignored easily, and then we need to make use of 6th column, 7th, 8th, 9th, 10th we don't want, 6, 7, 8, 9 and 11. Okay, so in our data set we want 6, 7, 8, 9, 11, 12. Okay, so we will do that, and we will name it as new train data is equal to train data all the rows, and we want only 6th column, 7th, 8th, 9th, right? 9th, we do not want 10th, correct? We want 11th and then the target value. So this is new train data. Similarly, we have to do away with the same features in our test data as well. So I will name it as new test data. This will be test data. We need to make use of same features from both train and test data. We cannot make differentiation. We cannot use some extra features while we are testing our model. Okay. So this is how we get the wanted data sets and wanted columns. Okay. So now what we have to do? We have to again run our k-means, k nearest neighbors using this particular set of lines. So I'll just copy this, and wherever I have train data and test data, I will make use of new train data and new test data. That's it. So this can be same, but for consistency, I'll just make this change. This will be new train data, new test data. Predicted value, there won't be any change. It will be new test data and predictions timed. Okay, so if I execute it, so you see how to score increased significantly. Earlier it was 0.81, right? And now it is 0.95. There is a significant improvement in our R2 score because we have done away with the features that are not required to predict the value of our target variable. So those variables which are not related with the target variable were actually bringing down our R2 score, right? So we have successfully identified them using the correlation matrix, and we have weeded away those columns which are not related with our target variables. Okay. Now you see the effect of the columns or features which are not important, how this affects our model. So this is an important aspect in every machine learning algorithm, not only k nearest neighbors, but you take any algorithm, you have to work with the related columns or related features only. Okay. So since we have done away with some of the columns and we are making only a subset of columns, even the runtime has improved. Earlier it was 1.4 something, right? 1.4. Now it has come below 1 second. So our whole process is taking less than 1 second to give our predictions. Now that we have new predictions, right? We will see how the predictions are looking using this particular plot. Okay. So do we need to make any changes? We can either make the changes or not. We can leave it as it is, test data, because the target value won't change really, right? So predictions, it will remain same, right? Predictions. So if I execute it, I am just checking the first 10 stuffs. So you see the distance between the predicted and original values, actual values, have been reduced significantly, correct? So if you check this, this is our actual, this is our predicted, actual, predicted, actual, predicted, okay? Now if you see the distance has reduced significantly. Now if you check all at a time, that will give some clumsy visualization, but to check for some of the data points, you can make use of subset of the prediction and actual values, okay? So let's check for all the data sets, okay? I'll say new test data. The same thing will come here as well, okay? And then I want all the predictions. I want all the rows in the last column. And there you go. If I execute it, you see yellow color are our actual values and blue color are our predicted values. Of course, there could be some more room to improve this R2 score or the performance of KNN. We can try with different neighbors, different number of neighbors, right? So we can change the number here to 4, 5 and 6. So you guys can try it. Or there is another concept to identify the outliers and then remove those outliers and then run the algorithm again. So that particular part I have not yet covered in my previous video, so I will not be covering that in this particular video, but you get the gist how we can implement KNN in Python from scratch, okay? So that's all for this video. If you guys have any questions, please post it in comment section. I will try to get back to you with the answers. So if you have not subscribed to my channel already, please do subscribe. It will help me and motivate me to further produce the quality content like this, okay? So till we see in the next video, guys, happy learning. Bye bye.